Of course, here's the rewritten text without headings. Somewhere in your body right now, your immune system has quietly eliminated one of your own cells, stopping it from becoming cancer and saving your life. It does this constantly. Most cancer cells that appear in your body are destroyed long before you ever notice. This is a remarkable task because cancer cells are not foreign invaders. They are part of you. Cells that once followed the rules suddenly begin to act independently, even if it harms the entire organism. Cancer happens when cells become corrupted and start multiplying uncontrollably. Since it can arise from nearly any type of cell, there isn't just one kind of cancer, but hundreds. Some types grow slowly, others are aggressive, some are easily treatable, while others are deadly. In a way, a cancerous cell becomes both ancient and new. Over billions of years, evolution has shaped cells to survive in harsh environments, competing fiercely for space and resources. But eventually, a new strategy evolved: cooperation. By working together, cells formed complex multicellular organisms like you. This cooperation, however, requires sacrifice. For a multicellular body to thrive, the health of the whole must outweigh the interests of any individual cell. Cancer cells abandon this agreement. They stop cooperating and start behaving like independent entities, dividing endlessly, stealing resources, and damaging the very tissues they belong to. Even though they cause great harm, cancer cells aren't evil. They don't want anything at all. They are simply protein machines following corrupted instructions. At the heart of each cell is the nucleus, which holds DNA, a long molecule containing genes, the instructions for building and regulating proteins. These instructions are copied and sent to ribosomes, where proteins are assembled. The specific proteins a cell produces determine its function, whether it's a skin cell, a liver cell, or a nerve cell. But if errors occur in the DNA through mutations, the instructions can become faulty. Some mutations are harmless, but others can give a cell abnormal abilities to divide uncontrollably, to ignore signals, to die, or to avoid the immune system's defenses. When enough of these changes accumulate, cancer can form. Fortunately, your immune system is constantly surveilling your body, recognizing and eliminating many of these faulty cells before they can become dangerous. If you want, I can also make it even smoother or more conversational depending on your purpose. Here's a rewritten version of your text. Smooth and continuous without headings. A corrupt gene means you get a corrupt protein, which will become important later. Your DNA accumulates tiny errors, mutations, tens of thousands of times. Every single day, most of these happen without any specific cause, simply as a byproduct of being alive. Almost all are repaired quickly or end up being harmless. But as your cells continue to copy themselves over years and decades, damage gradually builds up. It's like making copies of copies of copies. Over time, small imperfections sneak in like a smudge on a scanner or a torn corner on a page, and every new copy preserves these flaws. There are ways you can accelerate this damage: smoking, drinking, alcohol, being obese, inhaling asbestos, skipping sunscreen, or contracting certain viruses like HPV. But often, the simplest way to accumulate DNA damage and develop cancer is to just live long enough. In many cancer cases, bad luck is the only cause. To simplify, cancer usually requires mutations in 3 general types of genes. First are the tumor suppressor genes, or TSGs. These genes act as the cell's internal quality control. They detect and repair mistakes in DNA and prevent cells from multiplying recklessly. When tumor suppressor genes are damaged, cells lose their ability to fix themselves and start replicating without control. The second type of gene involved is called an oncogene. These genes drive cell growth and division. They were highly active when you were developing in the womb, transforming a single fertilized cell into trillions. Once development is complete, these growth signals are mostly switched off. But if oncogenes become corrupted, they can turn back on, pushing cells to divide uncontrollably. The third set of genes controls the cell suicide program. Most cells are constantly being replaced, and when they accumulate too much damage, they self-destruct through a process called apoptosis. If the genes that govern apoptosis are damaged, the corrupted cells lose the ability to destroy themselves and continue living even as they grow increasingly dysfunctional. When a cell can no longer repair its DNA, ignores the signals to self-destruct, and starts dividing without limits, it becomes a young cancer cell. At this early stage, these rogue cells are still weak and relatively easy to eliminate. But if they continue to accumulate mutations and multiply, they can eventually learn to evade the immune system and become a serious threat. At any moment in your life, your immune system is actively hunting for these dangerous cells. But how does your immune system identify and eliminate corrupted cells that, on the surface, appear nearly identical to healthy ones? This is where the proteins inside the cell become crucial. For instance, if oncogenes reactivate, they produce oncogene proteins. Your immune system knows these proteins shouldn't be present in adult cells. In order to monitor what's happening inside each cell, evolution came up with an ingenious solution: MHC class I molecules. These act like display windows on the cell's surface, constantly presenting tiny samples of the proteins being produced inside. This allows immune cells to see what's happening within each cell and recognize when something has gone wrong. Would you like me to also make a more casual, more dramatic, or more educational version? Here's a smooth rewritten version of your text without headings. Thousands of MHC molecules are displayed on the surface of each cell, constantly showcasing what's happening inside. This selection is continually refreshed, providing an up-to-date snapshot of the cell's internal activity. The immune system has a massive database of dangerous proteins that healthy cells should never produce, and billions of specialized T cells are trained to recognize them. If a T cell detects one of these forbidden proteins presented by the MHC display, it immediately identifies the cell as corrupted and destroys it. But there's a weakness in this system. What if a cancer cell mutates and figures out how to bypass this process? All it needs to do is stop producing MHC class I molecules. Without these display windows, the immune system becomes blind, unable to spot the rogue cell. Fortunately, evolution has come up with an ingenious backup plan: the natural killer cell. Right now, hundreds of millions of natural killer cells are patrolling your body, scanning for cells that have turned cancerous or have been corrupted by viruses. Unlike T cells, which search for the presence of abnormal proteins, natural killer cells look for the absence of normal ones. Their logic is simple: if a cell isn't showing its MHC display, it's likely hiding something and needs to be eliminated. What makes natural killer cells even more extraordinary is that they operate in constant kill mode. As they move from cell to cell, their default intention is to destroy. Your healthy cells must actively convince them not to kill by displaying their MHC molecules. If the display is missing, the natural killer cell assumes the worst and acts immediately. Thanks to this layered defense, almost all young cancer cells that ever emerge in your body are destroyed before they can cause harm. But if your body has such sophisticated defenses, why does cancer still sometimes win? The answer lies in the nature of cancer itself. Over time, some cancer cells mutate further and develop ways to fight back more effectively. It becomes an ongoing arms race between your immune system and the evolving cancer. Despite this, the battle is far from hopeless. Right now, new therapies are showing incredible promise, from cancer-fighting vaccines to engineered T cells and even modified natural killer cells. The war isn't over yet, but we are making rapid progress. Sooner or later, cancer may be eliminated completely, perhaps much sooner than we think. If you want, I can also